Okay, so now we have another problem. A population of 25 mice doubles each year for 4 years. So for A, we're asking what is the percentage of increase each year? So in this case, now for the solution, let's start with A. Again, we have our function that looks like y is equal to c times 1 plus r to the power t, okay? And in this case, we're also taking a look at, well, we want to know the percentage of increase, okay? So we already see r is the growth factor, and we say that it doubles each year, which means that the growth factor will be 2 because it doubles, okay? And the growth factor, sorry, is 1 plus r. R is just our growth rate, but 1 plus r is the growth factor. So 1 plus r will be equal to 2, which means that r is equal to 1. So the fact that our growth rate is equal to 1, this means that the percent of increase each year is at 100%, okay? It means that the percent of increase is 100% each year, okay? Because we know that r is between 0 and 1, okay? So always r is always between 0 and 1. Okay, so if r is going to be at equal to 1, then we understand that the growth rate will be at 100%. Okay, so that solves A. Now for B, we say what is the population after 4 years? Okay, so now again we have to understand at the beginning we have 25 mice. Okay, so C, which is our initial value, will be 25. We have R, which is 1, and we know that Y is going to be the population, and T is the time in years. Very important to identify your variables. So the function becomes then, let me change. Y is equal to 25 times 1 plus our value of R, which is, 1 to the power T. So we're dealing here with 25 times 2 to the power T. And the question is, what is the population after 4 years? So here, T is equal to 4. So Y is equal to 25 times 2 to the power 4, which is 25 times 16, which is simply 400. So your solution is that there will be about 400 mice after 4 years. Given our function. That is all.